and I might be limited by the frequency limitations of the PWM. I might also be limited by the fact that we're only doing pulse to DC right now, but that's irrelevant because I still want to try to get the numbers to see if I can get them as tuned as possible for when we roll this out for the Bedini circuit. Oh, did somebody just pop on?
Yeah, Mike and Lulu are here.
Oh, hey guys. Sorry, I can't really see you guys. I'll set up the laptop in a moment, so I have it off to the left. So the laptop I brought out because I do have this nifty little Arduino circuit that I whipped up a couple nights ago. And this thing is a signal generator. Now, it's not able to produce a clean sine wave itself. It produces a square waveform. So we could do some experimenting with that. But with a potentiometer, I might be able to hook it up so we can adjust the frequency with this as well and not just have it set at a specific frequency. So this is a very simple circuit. It's just got 2 capacitors, a transistor, a 2P PN2222 transistor, and I think that's a 100K ohm resistor.
So, Ben, you are in DC right now, right? Your power supply is DC?
Yes, the power supply is DC. And with this setup, we are pulsing the DC at, right now we're at 26% H duty cycle.
Okay.
2K frequency.
Hey, guys.
Hey, Mike. So let's increase that duty cycle a little bit. As we increase it, hey. So as we increase it, you'll see the voltage output increases and it gets closer to the input, which is really good. We want the most efficient system, but we want to also monitor the amperage as well. So it's going to be a little difficult with one multimeter, but we'll manage. Right now we're at 38% H duty. And I noticed it, like you guys said, it caps at like 50, and then after 50, it really doesn't do much, or it doesn't do anything with the voltage. And see, I'm at 50 right now, 3.1, and after 50, it really doesn't do anything.
You're talking about 50% duty cycle?
Yeah. Now it's just stuck at the same number. Oh wait, hold on. I capped it. Let me uncap it, and then we'll. But it basically, it doesn't do anything. Yeah. What's up, Mike? Sorry.
That PWM, you can change the signal from a square to a sawtooth wave.
Really?
I think so.
How do you
I
do
remember
that?
reading that it has more than one signal. It's not just square wave.
Huh. I'll have to look up how to do it. Yeah, I had to look up how to do this. So yeah, see, we just increased it 61% duty, and it just kind of took a crap on us, right?
Sawtooth is closer to an AC signal. It's just not. It's not
Oh, right. Like it's closer to replicating it, as close as you can get, right? No, that's what we want, though. We want to try to get as close as we can get.
A gradual rise, gradual fall. Unlike a square wave, is a sudden rise and sudden fall.
But look at this. We're at 50% duty, 3.1 on the output, 3.8 on the input voltage. After this, it doesn't do anything. It just goes down. 52%, 55. Then it went down. 55, it went down to 3. It just takes a crap.
When you say went down to 3, what are you referring to? What is
we got 3.8 volts going in. And right now, when we're at 50%, which is our max threshold, it seems. Yeah, 50% H duty cycle. It's at 3.1 versus 3.8 on the input. So it's close.
You mean
but
voltage?
As soon as we go, voltage. But as soon as we go above 50%, the voltage takes a crap on the output.
Oh, you're measuring the voltage drop. So you got 3.8 on the input and 3.1 on the output, right?
Right. But as soon as I'm at 55 now, it dropped to 3.
From 3 point on the output voltage or the input voltage dropped to 3.
The output dropped. Yeah. It seems like 50 is the
3.
Yeah,
Hold,
50 is
hold
the
on,
threshold.
Ben. The output from the power source
Yeah, it's a
or
little more
the
focused.
output from the coil?
The output from the coil. So we're monitoring the output from the coil right now, and we're monitoring the current before it's entering the circuit, right? So just the raw power from the output of the coil.
Well, it should drop if you remember your wires are crossing in your coil, so you're going to have canceled signals if you go up too high on your frequency duration.
So that's the
Yeah.
explanation then. Yeah, that makes sense. I'm going up too high.
Oh,
And
you're changing the frequency
it's-
and then you see the drop. Okay.
right. So it can't go above 50% duty. Otherwise, the voltage on the output just takes a dump.
Well, yeah, because then at that point, it just thinks you're putting a solid signal in.
Right. It's not really pulse. No, this all makes sense. It's coming together for me in my head because I don't know anything about pulse DC. This is all new to me.
You have to factor in the geometry of your coil. You have two crossing waves, and when they cross each other, because of the design, they start to cancel if you don't have them intermittent.
Right. Okay, that makes sense.
Plus, there's the kickback, which happens right after the coil is saturated, and if it's pulse DC, and then when the coil's desaturated, it kicks back right after it desaturates. So whatever time it takes to saturate the coil and then desaturate, that if your frequency is matching that, you could cancel your signal on the rebound, because it's gonna the coil's gonna rebound. If you don't have that rebound going out somewhere else other than the coil itself, it's going to hit smack right into the signal that you're giving it from the source.
So, Ben, you're in magnetics right now when you're in DC. So the best thing for you to do is put that neodymium near it and then play with the duty cycle a little bit and see exactly what it's doing.
Mm-hmm. Yeah, that's a good idea.
Because you're all the way on and then all the way off on that signal. You're not gradual rising and falling.
Right, that's the difference between the square and the sawtooth wave. You can get a gradual rise, and that will kind of eliminate that, no?
Well, he'd have a more progressive signal coming out of there that give you a better rotation on a magnet. That's for sure with the sine wave.
Right. The gradual rise gives the magnet the gradual turn.
This way, if you put the little cup in there with the little tiny magnet and it jumps, it would probably tell you more about your duty cycle than it would the rotating magnet.
Like there's on the Arduino, you can program it for on time and off time, which completely changes your frequency every time you change those values.
Yes.
I'm trying to find a way to, well, you could still do 1% on time and 99% off time. But then how do you slow down that cycle and give it pauses in between? Like instead of as soon as you go from 1% on to 99% off, right after the 99% done is passed, then you go back to the on portion again. How do you?
In the Arduino, you have to write it as a timing circuit.
I'm saying, how do you extend that 99% off time with a timing circuit? You can't. They're not capable of doing that.
In the Arduino, you can, because you can program it. So you can program the on time and off time on there between each interval.
Yeah, but the on time and the off time have boundaries of 100% between the two of them.
Right. So write it to 10% for the on time and 90% for the off time.
Off time, right? What if you wanted to do 10% on and 90% off, and then wait another 90% before you go on again?
Right. That's what I'm saying. You write them between intervals. So
you got to show me that off on the site some other day, because that's programming, right?
Yeah.
Yeah. Okay. I didn't know that. I really want to do that though. I don't know how to do that. That's programming. off intervals. Yeah, I have no idea. I know you're talking about programming, but I don't know what
So
exactly you're talking
regarding the neodymium sphere, I don't think it's going to be doing much unless I can get the frequency lower than 1 kilohertz, which is the minimum for the PWM. If I can hook it up to the circuit, though, to kind of restrict that frequency and draw it back a little bit, maybe with like a capacitor or something and a resistor, we
That
might be
will
able to
absorb
bring
the
it
reflection.
down. But I don't know if I have enough capacitors and resistors for that much. I mean, to get the effects that I was seeing, I had to get really low, like below 20 hertz.
So, what exactly are you achieving with this setup, Ben?
Right now, I want to see exactly what the sweet spot is for the coil. So when I have the batteries for the Bedini circuit, we'll be able to hook it up and just have it, perfectly tuned, right?
Trying to figure out the right duty cycle for the coil and how long it takes for the coil to fill up with energy,
I mean,
so you don't
and
charge
we
it
might have to,
longer than it needs to be charged.
and I could imagine we might have to adjust it a little bit when we actually add the Bedini circuit, but it's a good starting point to see our limitations at least,
Hey, Ben, you got that small magnet?
The what?
The small magnet?
Yeah, the little tiny saucer one or the disc one.
Yeah, throw it in there in the cup, and then turn your duty cycle down to about 30.
Uh-huh.
And then you're going to play with your volts and your amps a little bit, and you're going to try to get that sucker to just see if you can't get it to flow.
Okay. So you said bring the duty down to 30.
Yeah, don't go over 50, Ben, because then you're distorting the signal, I think, or you're just overcharging the coil. It only takes so long for the coil to charge up. You don't want to keep charging it after it's charged already.
Yeah.
That's the duty cycle right there. So you got to figure out how long does it take for that coil to charge up, And don't
Is that magnet moving?
No. We're at 11 volts. No,
how many amps do you have?
1 amp and 17.9 volts.
That's 17.9 watts.
So turn down your voltage a little bit and don't go over 3 amps.
Okay, so we're at 15 volts. I'm sorry.
18 watts ain't going to burn that supply.
15 volts, 0.88 on the amps.
It's a 50-watt supply. Yeah, okay.
So what was that reading again? You said 15 volts and how many amps?
0.88.
Okay. You need a magnetic signature in there, Ben. And then you also need the voltage, but don't go crazy on it. I'd love to tell you to fry it and find out, but that's not going to work for you. You getting any movement?
No.
Is this the same
what did
coil?
you do? Go ahead, Lulu.
Is this the same coil that, or a couple days you were getting movement with?
This is the Mark 1. I actually haven't hooked it. I'm going to hook it up to the Fireball coil in a minute because that has a bigger field.
Yeah, he hooked up the PWM. He got it to move pretty well. And are you changing the signal wave now? Is that what you're doing?
No, but I'm about to change the frequency.
You just need to find a response point, Ben.
Ben, didn't you say you had it running already with the PWM?
Yes, but the PWM is hooked up and running, but I never got anything electromagnetic field generated strong enough. I had a feeling it's because it needs to be a pure AC wave, though. We need to have the oscillation.
Oh,
Yeah, at least for the
How-
magnetic and like for this type of circuit. Like if we had a Bedini circuit hooked up, we could actually probably use the pulse
I'm
DC
confused
with that
though.
circuit to.
I'm confused because with the PWM, you had this the magnetic sphere rotating like crazy. How is it you're not getting a magnetic signature?
No,
I
I never
agree.
got it rotating with with the PWM. I had it
Well,
hooked
what
up
was?
to the stereo amp.
Oh,
Yeah.
that's what you had it hooked up to. I thought you had it hooked up to the
Yeah.
PWM.
I got it
Mm.
to jump a little bit with my signal generator in a square waveform. But it only jumps when you like kind of like power it on. You know, you get that spike.
Yeah.
Yeah, so
Well, the
it's
coil's probably wound for an AC wave to, you know, it's probably more suited
Yeah,
for
it's
an
just-
AC wave.
yeah, without the Bedini circuit, it really needs the oscillation, the resonance for the AC to do any kind of like energy production or magnetic field, it seems. But with a Bedini circuit, you're not resonating just the coil, you're using a resonant circuit, right? You're resonating the circuit with the pulse DC. So you're at that point, the coil is just an extension and utilized for extra efficiency.
Yeah, well, an AC is oscillation, and the DC pulses is pulses. They're not oscillations, but they're pulses.
Right. Well, there's just a difference in system, but it is a practical use for this system right here. We can't really see it. You know what I mean?
There's
I don't have
no,
the equipment to hook it up right now. Like if once I get the batteries, the car batteries, we can see something.
So where you at on your duty cycle?
30%.
Bring it down to 10%.
10%. Let's go down.
So now you're trying to get the PWM going. Is that what it is?
Yeah, you're trying to get
Yeah.
that thing to jump a little bit.
Yeah, maybe we can get it to jump. Who knows? Like
So try this.
Nathan.
Try this.
Nathan
Put
might
the
be
power
onto something
supply
there.
down to 5 volts and turn the
But the thing
duty
is, if
cycle to 100.
if we can get it to do anything, it's going to be like Nathan said, we have
Or
to really
90.
find and tune that precise that point.
You might need to you might need to turn the duty cycle up to 90 and lower your voltage. In other words, give power to the coil for a longer period of time with a lower voltage, or just to protect you from burning out on anything. Turn the voltage down when you do anything, and gradually bring it up. But try putting the duty cycle at 90% and 10% off, because it might take longer to charge up that coil with DC than it does with AC.
Yeah.
Which makes sense because it's a very long piece of wire. AC doesn't take long to go through a long piece of wire. It goes very quick.
And then we're gonna change the low.
And you might be able to lower your frequency. I don't know. Can you lower? Does this have a duty cycle setting and a frequency setting on the PWM?
It does. You can set the low percent and the high percent for the duty. You can set the frequency from 1 kilohertz to 20 kilohertz in 100 kilohertz or 1,000 kilohertz intervals, I think.
Just put it like
I think that's the
1K,
intervals.
1K hertz with a 90% duty cycle, and there you go.
I think
Your hertz may be way off, Ben. You may be
Well,
way
yeah,
too
well,
high.
That's
Or
what I'm
low
saying,
500 or
Nathan. I think
300,
we need.
lower it.
I think we need a lot lower range, because the only time I've ever seen this coil produce that electromagnetic field really
It's
is
DC. You need to hold the contact
under
down
20.
longer for the voltage to get across the coil, so it needs a longer duty cycle. It's DC.
Yeah, and it also needs a lower frequency too. So
A lower frequency.
I mean, we
range.
can hook it up to the signal generator. I have the Arduino circuit in a minute to see what happens. But I'm actually I want to move to the Fireball coil because it is a bigger field, and it seems to amplify the field a little bit easier. So I'm gonna bring that out a little bit so you guys can see that it's on the floor.
Yeah, Ben, we're in DC, so get it down to 50 hertz, man, 60 hertz, and then pulse it.
What
Because
is the
you're
No,
way too fast. You're
yeah,
running at Tesla coil speeds. You're not a Tesla coil.
I have the signal generator all ready to go. I think it's at like 10 hertz or something like that.
What does the knob do on the PWM? Is that regulating the frequency, right?
Yeah, I mean, I got a bifilar coil and I run it at 60 hertz and it produces the magnetic flow all day long.
Right. It's
And
probably
then-
too high a frequency, not a long enough duty cycle because it's a long wire and he's running DC through it.
Yeah, it just seems like a solid wave to it. That's all it feels like over there. It's like when you hook up your
He
Tesla
was getting
coil
it to
wrong.
run with, Nathan, he was getting it to run with AC because AC cuts through the wires in no time. A long span of wire, you know, AC goes.
Well,
through
yeah, because it rises and drops steadily. This thing immediately does it. It goes on and off so fast right now with its frequency, it doesn't know where the off switch is.
What I'm saying is, it takes longer to charge the same coil with DC than it does with AC.
Well, no, he's saturating the coil.
Right, but it takes longer to saturate the coil with DC, the same coil with DC, as opposed to AC.
Yeah.
Oh, you
Okay.
say, yeah, if we get it to work, it might take a second, is what he's saying. Yeah.
But he saturated the coil with the frequency that he put in.
Yeah, and
Each
Nathan,
pulse-
you're
I mean,
right.
each-
It's
each
just
pulse,
too high a
each
frequency.
switch,
You can't tell.
Each switch, each contact takes longer to charge the coil.
Yeah,
Because
I'm not arguing with that, Mike. I'm saying that he saturated it in DC already
Yeah.
by the frequency. That's all I'm saying.
Only constant DC will saturate the coil. You have to, when you're pulsing DC and you disconnect the DC, it desaturates right away.
But he's pulsing too fast. His frequency's way too fast.
it's
I
just the
think
wrong
he's not.
range, so.
I think he's not charging the coil with long enough to get the DC from one end to the other.
It could be both, but
And that's the duty cycle.
we're
I
gonna
was
hold
telling
it
him to put the duty
fireball
cycle
coil.
lower before. I didn't have any problem running at a low duty cycle with DC, but I had my voltage up around 27 volts, and I was
That's
getting it from batteries, not power supplies.
That's what I'm saying. It's rapidly on and off so fast that
And
it thinks it's always on.
Well, yeah,
Yeah.
but he's between
And
5 or
it-
10 volts.
and Mike,
the higher the voltage,
remember
the better.
Mike, remember these coils? The reason why I told Nathan that the Joker coil is appropriate is because they play tricks on you. They really do. They do weird stuff.
I'm not familiar. What is the Joker coil? What is that?
Oh, it's show him, Nathan. Pull it up.
I've never heard of this.
Oh,
So that's his new prototype.
Oh.
I made a glow in the dark coil.
How? How'd you do that?
I 3D printed it that way.
Is
So
that it?
yeah, you put it outside for a little while, and it'll glow, and then
That looks like a.
that's the
A
original
housing
color
circle.
right there. So it's like a clear, and then it's a little bit purple, and then when you see it in person, this glow is really purple.
That's the frame for the coil, no?
Yeah, it's a frame. I got to wire it.
How did you get that? Good, that plastic. They make it for the printers or something?
Yeah, they did. I didn't do anything special. They did it.
Oh, cool. That's a
Very-
smart idea. Boost sales.
All right, sorry. Let me remove this.
Yeah, your coil is. I don't know the impedance on it, but if you have 10 volts and you have a high impedance, it's not going to get through fast enough to create your magnetic effect with DC. But AC will, because there's no delaying AC getting through a long span of wire, you know. That's probably why the Nunez are saying to use AC, because it's easier to get going with that.
Okay, Ben, check this out. SNA Ordinate Creation says, with one of my interference rodent coil devices, I get movement from the magnetic ball with 30 to 40 hertz, 5 volts, 1 amp, 35% duty cycle. So we're in the wrong ballpark.
Ooh.
Well, no,
Yeah,
hold on.
what was the
Ask him-
frequency? What did he say the frequency was?
SAE, what is the ohm on your coil? The ohms. You're missing that most important part.
So 30 to 40 hertz,
Yeah, 30 to 40 hertz.
Yeah, but
5 volts.
1 ohm coil is going to be easy to get through. Ben has like
I
a
got
10
an 8
ohm,
ohm
15,
coil.
8 ohm coil. It's a big difference.
Yeah,
How many
but it's
ohms
a
on your
starting
coil,
point.
Amy? That's an A.
Yeah,
That's an A.
definitely. So no, this is a
Organ
starting
length.
point. So I can load my
Crazy.
signal generator with around that frequency range and see what happens. I just have to hook it up. Give me a second.
8 ohms.
Mike, he says he doesn't have any idea what the ohms are.
Yeah, most people forget to measure that on their coils. I make it a point to never forget that now, because it tells me how many volts you need to give it to get any kind of current through it. You know.
Yeah, that's the threshold right there. No, that's important for sure.
Well, I know with my bifilar coil, I hook up a 19 volts, 3 amps, and it's on a duty cycle because the power pack itself is junk, so it doesn't smooth out the signal all the way. So it'll run just fine with a magnet on there, and that's at 60 hertz, I think it is. So I have no problem with that. So I think where he told him to go is probably right. Let's see, lower frequency to start because you have to complete it with all the move and the mass of the magnet. Yeah, that's why we wanted to start with that little magnet, because even if you put it on your fingertip, you can see where the movement is, and you can start to see how fast it's pulsing, and then tune it from there.
What is that? Nathan, what's the voltage he's using? 5 or 10?
I'm sorry, what?
What's the voltage he's going with? 10 volts about? 10 volts?
He should be,
That's his average running volts?
yeah, 5 volts, 1 amp, 35% duty cycle.
No, Ben.
And I'm sorry, what?
What voltage has Ben keeping this thing at? 5 or
Well,
10
hopefully
volts?
that's what he's setting it at, because that's what was suggested. So here, I'll bring it up on the screen for you to see it.
Yeah, bring it up on the screen. I have the Arduino, so I'm going to need to reprogram the Arduino. So I need to see so I'm going to head over to the workstation real quick so I can reprogram this.
Yeah, that DC is definitely a different animal than the AC going through there, Mike. I agree with you.
So here's the thing. He's using about 5 volts. If you put 5 volts across an 8 ohm coil, it's going to draw 625 milliamps, a little over half an amp, which sounds to me, that's twice the amperage that the Bedini motor requires to run. Which is, so he should have it. I think the magnet is, because it's a neodymium magnet and it's a sphere, I think it's probably not close enough, the edges of the sphere and its field, because they're very short range, these fields on these neos. If he had the same magnet but spherical but ferrite, it would spin no problem, because the field's like much wider.
Yeah.
So I think he needs a ferrite magnet, if not a neoferrite magnet, just a standard square ferrite magnet for him to put in his hand and fish around that coil to determine where his strength of his field is going when he's moving the settings on everything. Because that's how I do it. And I don't use a neo to do that because the range is so limited and you got to get so close to the thing. And by the time you do, it just grabs you and pulls you in. You can't really measure anything like that,
Gotcha.
But you got to use a handheld square like magnet that's big enough to pick up the field real easy. A ferrite, regular ferrite, and just keep it in your hand, move it around the coil so you can determine what's going on better,
Yeah, well, I like a ferrite magnet better, but this is what he's got. So one thing I will tell you is when you got that magnet with the DC, if it jumps and then does nothing, that means that you don't have either the frequency right or the frequency range right or the pulse right, because it feels like it's on all the time. So it'll jump once and then do nothing.
Well, he had it at 7.43 hertz with the AC signal, and it was operating like that. That's a low frequency.
The difference is, like you said, it rises and falls gradually. A DC will be on and off.
He mentioned what the L percent for the duty cycle, the low end, was.
Oh, the duty cycle? He said 35% is what he said it at.
That sounds good to me. It's less than 50.
So is that the high or the low, or is that just
that's the on time?
The on time, okay.
Yeah, the high. That's the high. High means on, low means off.
Which should I keep the low at just default then?
What is default for the low?
I'm not sure. Probably like 50%. I imagine.
Oh yeah, no. If you can change that, then are you doing the adrenal?
Yeah, I can change it. Yeah,
okay.
Yeah. So I need numbers for it.
I'd say put the low at. Go ahead, Nathan. Do this one. How much on and off time? The high and low.
Well, he wants the low at 0, and then he wants the frequency to come on all the way at 35%.
But he wants the off time. How long does the off time? Like, how much percent? Can't be 0.
So hold on. I'm sorry. He wants the amount of energy to go in to be 0, and then it go up to 100%, and then cut off at 35% duration time.
He's messing with the Arduino. It's a high or low. High means on, low means off. So he's asking how much high time and how much low time.
So he's asking for the duration.
Right. How much? Yeah. So the duty cycle on time is the duty cycle. So that's the high, and the low.
So he wants 30. He wants 35%. So I don't know what his breakdown is in his Arduino is per second.
Just Ben, put the high at 35%, or what is it? It's by numbers, right? Trying to remember.
Yeah, I'll just set the high 35% and keep the low out of it.
Yeah, maybe the low is 50%. Like the default is 50.
Yeah, you don't want to confuse it.
I wasn't able to get. It's like it's 999. You know, before it hits the unit 1, so it's like 900 or 1,000. So it's the Arduino is 1,000. So you have 1,000 digits of on or off. You choose between the 1,000. So you can have 999 on and 1 off, or 1 on and 999 off, or you can have 500 on or 500 off, or 300 on and 700 off. You see how it works? That's
350
thing.
There's 35%.
Right, and then the other one would be 750. Ben, it's right. That's 350 and 650, right? It's 350 and 650. 650 low and 350 high.
Now I remember why I don't program with this thing anymore.
Yeah, it is confusing. Yeah, but it's worth it. It's because it's so sensitive. These Arduinos, you can get accuracy like crazy.
Oh, I understand. That's why I take the power pack, the junk one that has that pulse in it, and I use one of those just for testing to see my range, pull the numbers off of it, and then see where I need to set everything.
You know, recently, I don't know if you're familiar as how, like the flyback thing with the Bedini circuit and all, but I just realized why Bedini did not fly back into the same source battery with one coil. And that's because the flyback plus and minus short each other out even through a diode in the circuitry if you do it that way. But if you fly it back in to another battery, the plus terminal of the battery does not host a shorting point for the positive and negative of the flyback of that coil. I'm going to make a video on that. Don't worry about it. Just forget it what I just said.
Right on.
I know that went right through.
I'll have to see what you're saying.
It's I'm trying to say that it's like shorting out a battery when you do it with when you try to send the flyback back to the same single battery system. It's like shorting out. It's like shorting out the flyback to itself when you don't have the second battery.
Oh, gotcha. Okay.
So you kind of like cancel the flyback by trying to, because I did this before. I was sending the flyback back to its own source, a single source, not the 2-battery system. And when you use this, the way the circuitry is, you have to connect certain points. And so I was sending the flyback back to the same battery. And I was probably not getting any results like that. I just realized now, but because I was shorting out the flyback signal to itself, the plus and
that
minus.
would make sense.
I'll draw it out though; it will make even more sense. It's when you can see where it touches the plus and minus of the flyback are hitting each other on the same plus terminal of the single battery.
Mm-hmm.
But if you add a capacitor and let the capacitor run the system, and you can isolate the flyback to the source battery with a timer.
That PWM signal generator he's got, it doesn't go down to that low in the hertz.
It's 0 to 20,000.
Then why is he playing with that Arduino?
It's 1K. It only goes to 1K. Yeah.
We don't need it at 1K. We need it at 50, 40 hertz. Just turn the thing down.
At 1K, the only way I could see it to operate at 1K is to lengthen the duty cycle.
Yeah, but 1K is the low. That's the high, isn't it? Shouldn't that thing turn all the way down?
1K is the low, right? 20K is the high frequency.
Yeah, 1K is the high. We don't need 1K. We need to turn that thing way down.
Yeah, it doesn't go below 1K, I don't think.
Well, that would be a piece of junk.
Yeah. Well, it's only $10, dude, and it's 150 watt. I just thought it was a good deal. And it is a good deal because it's 150 watts.
Well, yeah, but you need to go from 0 to 1K, not from 1K to 1K. That doesn't make any sense. Something's wrong there.
No, 1K to 20K.
Okay. Which would only make good sense on an AC signal. It would make sense on a DC signal.
It's a DC pulse width modulator. It just pulses DC. You can pulse AC too. A ground plane on their coil to capture and reflect the focal point of the vortex is where the accelerated angle.
I'll tell you what, next week I'm going to have my coil up and going and we'll compare tests because we need to figure it all out here because
you have access to some better equipment so you can do some more interesting tests.
Well, I got access to some of the parts that you have too, the frequency generator, the $10 one, stuff like that. So we'll just have to put it on there and find out.
See, with the stereo amp, he's able to put a signal generator in their signal, just a signal in there at any frequency he wants from his laptop. So he can go to 7 hertz if he wants, but it's AC 7 hertz.
Right, we're going to test the code out in a minute.
But he can also pulse DC through the signal generator into the stereo, and it would be the same thing as the PWM. Pulsing
Gotcha.
DC from the supply, because it's pulsing a DC tone. but he can't get 150. He can't get 150 watts or the full 50 watts out of his power supply with a clean signal from a 150 watt signal generator. Because you got a 150 watt signal generator only being demanded to push 50 watts at the most, and it's going to be a clean signal.
All right.
Something tells me it could be a lot easier.
Oh, it's going to be a lot easier when I get my mini signal generator. I have a little signal generator and oscilloscope coming sometime in the next couple weeks.
Oh, well, you got a handheld portable oscilloscope coming?
Yeah, it's going to be a little handheld one.
Those
but
are
it's
awesome.
got and it's really nice. It's got.
It's
all
worth
the
it to buy that than the big one because it's a money saver and it's more convenient.
Yeah, and it's like it meant for automotive work. So I don't know. It's really nice.
It's smaller than a cell phone. And it is USB charger and lasts 3 or 4 hours on the charge.
Yeah, I got the small one, and I didn't like it. It's just too many little buttons that do too many multiple things, and it just irritated me.
So I just got the email from Mike K. If you all want to get ready for the live stream on Mike's channel, we'll switch over in about 15 minutes.
It's real easy once you get used to using it. It's a piece of cake.
Once I get in, I'll add the channel.
You can zoom into the signal pretty damn well. I mean, it's like it stretches out the signal pretty good. Enough for me anyway.
I get it.
I could see the spike real well enough on it. It's not like the best oscilloscope, but it's for $50 and being so small, you don't have to tug it around or it doesn't take up any space on your, if you want to jump from one little thing to another with it, you can move the oscilloscope around real easy. It's just amazing. Whoever invented it is doing well. When I saw that thing, I just jumped on it. I couldn't believe it.
Nice.
$50, $49 on Amazon.
Yeah, there was a couple of small ones I was looking at, but I like the big
one
one so I can break the waves down better.
Yeah, well, then you go, then you get the big one for that when the real one. But how often are you going to want to do that?
I have to do it every day.
Yeah. Like you're analyzing the signal to discover something that you just want to know the frequency,
Well, I'm trying to hit a specific point to amplify, and I want to hit the timing just right. So it's better to see the signal as big as I can. You know what I mean?
Yeah. Well, those things are not cheap, man. Those big ones are like $1,000, $600.
I paid $200 for mine, $250.
Is it a digital one, the new ones that tell you the signal without you having to, figure it out with the graph?
No.
There you go. That's what I'm talking about.
That's not what I wanted.
But the handheld one tells you the signal. You don't have to graph it out.
Too many advanced features screw things up.
I don't know, man. That handheld one's pretty accurate. I'd be turning the potentiometer ever so slowly, and it changes the frequency. Yep. It's impressive. I'm impressed. And I don't have to look at the graph to figure out, how many signals I have in one, and a certain amount of squares to determine what the frequency. That's the old school oscilloscope. The new ones will also tell you, do all that math for you real time. And you'll see the frequency change, like real time.
I have that. I don't have that super digital one.
Right, the digital ones do that. The analogs, the old analog ones are awesome.
No. I have digital. I don't have expensive digital. Where
if you have digital, it probably does it. You just haven't found it yet. Look closer. It's there. It's there. Get the manual out or something. I'm telling you, if it's digital, it can convert the graph for you, and it should. There's no way they would make a digital one to do anything else. I mean, especially that.
I think we're talking about two different things. So I'm going to say you're probably right, but I'm thinking about something else.
The digital oscilloscopes automatically tell you the frequency of your signal. You don't have to.
I know that.
Right.
You hit the little math button and it shows you all of it.
Right, but the analog old oscilloscopes, which you can find for $200, don't do that. You have to map it out.
Yeah, no, they sell a bunch of them on Amazon for cheap, man, for $250 for one that'll work for you if you're a normal home lab.
It's like a 5-minute process every time you want to know what your frequency is every time you turn the knob.
I find my frequency within seconds as soon as I turn it on. So we must be on the same page of what it's doing.
Oh, no, you can find resonance and you can tell when you're in resonance, but you need to know what that frequency is. And to do that, it takes about 5 minutes on an old scope. But a new one, it's right there in front of you right away. And it changes as you turn the knob.
Okay.
That's what's the benefit of it, in my opinion. It speeds up things when you're trying to, experiment and stuff, see what's going, figure shit out.
All right, Ben, you got your code in there?
And I didn't want to spend $600, $800, $1,000 on an oscilloscope, or even more sometimes. So I just I saw a digital one that was handheld for $49. I knew for sure that was going to tell me the frequency because it was digital.
Gotcha. Oh.
Yeah, there's no point in putting all those mathematical chips in there and not have it also do the math for you, right?
Yeah, I'm just thinking about different levels of oscilloscope. So there's the cheaper end, which I have, and then they go up from there, and then the ones below me are the handheld models. So,
right, I don't even know if they still make analog oscilloscopes anymore. I'm not sure. They might, but I think they're all digital now. But they used to be analog. There was no digital. And most of the stuff, you find on eBay as far as oscilloscopes that are, have big screens and all that and give you a nice close up of the signal. They're analog.
So we didn't really get any effect. I suspect it's because I don't have the potentiometer and ability to tune it from 30 to 40, but I'll get around to doing that at some point tonight while we're discussing on Mike's channel. So we're gonna get ready to head over there in a few minutes. Don't worry, I'm gonna try to broadcast it on my channel if I can. I don't know if I can, but if not, we'll post Mike Faraday's channel in the chat as well.
Ben, your power supply is 50 watts, right?
I don't think it's that high. I think it's either 25 or 40.
That's the problem right there, Nathan.
I want to say it's 25. It's
coil
very small. Yeah. Okay, Mike. Nah.
You could swap it for a car battery. That car battery will push.
Hold on, you saying the power source is what now?
The 25-watt power supply.
That's not possible.
No, 25 volt max, I believe.
Okay, yeah, that'd be a different wattage.
How many amps?
Yeah.
The 5 amp?
I'm not sure. Like
I think you probably got 5 amp.
Yeah, probably just 5 amps. It's a very small, cheap one. That's that's
100
all I can say. Yeah,
no, 125.
It's just enough to do a little bit.
Yeah, he's got plenty of power in there to do what he's doing.
Yeah. I didn't want to overdo it with that because they get expensive,
Yeah, I got those power supplies. They suck, man. When you run high voltage to them, they shut off every 2 seconds. It makes you want to throw it across the room. It sucks.
That's why you can just put a couple car batteries in series, get your voltage, and not worry about burning anything out.
Oh, well, yeah, I just hook up my drill battery and it works just fine.
Yeah. Right. I don't really like power supplies because they have those protective circuits in there and you can burn them out as well, even without that. Mm-hmm. I prefer the batteries as a power supply, to be honest.
Yeah.
So in case I can't stream tonight's League of Extraordinary Inventors, here is Faraday Research's channel. We will be joining him momentarily. Sorry, guys. I just wanted to give everybody an update.
Like the best batteries, power supply is batteries with a capacitor bank to, handle the loads and preserve your battery.
Hmm.
You know, in parallel with the batteries, you put capacitors, and those capacitors protect the batteries from any stress.
Got you.
And that's like my vision of an ideal power supply that I'll never have to worry about, losing it,
Yeah.
As long as you keep a slow trickle charge on it, so don't get too low in voltage. And it's like at least like a 50 amp hour battery at 12 volts. That's a good one. Bedini was saying 13 and a half amps, right? I mean, you can go higher than that, in my opinion, because, you don't ever want to stress out the battery in any way. So the more amp hours it has, the better.
Interesting. Well, we'll get into that when we hook up the Bedini circuit for sure. We're going to need to dive into more Bedini, and I'll be rewatching a lot of his videos at that point.
I've been listening to him for quite a few years, and it wasn't until recently I started to catch on to his thoughts of not using current, mostly because, Mike Faraday kept drilling it into my head.
Sometimes sometimes just hearing somebody say it a different way or,
higher voltage, get rid of the current. And I mean, don't use too much current if you can avoid it,
Yeah, because the current is just there to provide
for a little bit of push.
Yeah, a little bit of push. Yeah.
That's it. That's all you need.
Interesting. This is cool, guys. I'm excited about Nathan's coil. I don't know about you all, but I'm really excited about it. Nathan and the nested coil, like those are two really, really neat ideas. I'm definitely going to be printing a nested coil at some point. I'll try it, but I want you to be the guinea pig for that one.
We'll have to change the STL because I don't like it. There's angle problems in it, and it wasn't compensated for, so it makes a crappy print. So
angle problems?
Yeah. Here, let me grab one.
Yeah, at first I thought he said something else.
No, I didn't. You got thinking the wrong stuff here. Come on, buddy. So right there, these little pieces right here, they all break off because they're junk.
Too thin.
Oh, yeah. You need
He
more
tried to
support
slice
from
something in half, and he shouldn't have, and he should have just notched it, and it made for a junk print. Or you could put a giant raft under every one of these when you print, which basically means you're going to waste a bunch of PLA for no reason.
What gauge are you going with on that wrapping? It's by far.
Well,
right?
Yeah, I'm going to try 28 gauge on the outside, and then I want to go down to maybe 20, 23 on the inside one.
On the inside, yeah, that's a good idea.
So it's two wrappings. It's not two wires wrapped around each other, but two wires wrapped around that spool, right?
Yeah.
You're not like twisting the. You're not twisting
two coils
wires
here.
Together.
Hold on.
Are you twisting the two wires together before you wrap it around there, or are you twisting the two wires around the thing?
So hold on. I think we're thinking in the wrong dimensions here, Mike. Give me a second. So
I think there's a slot so you put the nested coil in after the frame is assembled, right?
Yeah. So hold on. No,
What the hell?
you build your nested coil.
Oh, you build it frame. Okay.
Put it in, and then the regular coil goes right on top, and then it locks in.
I see.
And then that one gets built. So once it's done, it's done. So if you want to make them resonant to each other, you got to weigh the magnet wire.
Weigh it?
Yeah, so you could tell exactly if it's going to be resonant because it has to be the same amount of copper that goes in both of them to make it resonant.
Oh, the same amount of grams of copper? Really?
Yeah.
Yeah, it has to be asymmetrical. Like these are not symmetrical because these coils, remember, they operate as a 1-to-1 transformer. If you off that one and you make it asymmetrical in any way, or at least for my coil, it doesn't work.
I got a question for the physicists on this symmetrical thing. If you have the same amount of copper with two coils, but they're different geometries. Is that symmetrical?
It's still going to resonate. It's like
they'll be the same frequency or whatever, right? Matching.
You know what I'm saying?
frequency
If you have the same two coils with the same amount of copper,
or harmonics.
one square and the other's round, is that symmetrical?
we'll have to ask Gerald because
No, I mean,
I'm
Yeah,
pretty
that's
sure
a
it
good
will.
question for Gerald.
You see
It
what I'm
will
saying?
depend on it will depend on the resonance and the vibration of like
I guess
Okay,
the
so-
mass is symmetrical, or the matter, or
because
whatever, the mass is
because you can
symmetrical,
have
but
right you can
geometry is
have
not.
different shapes as long as they're resonating at the same frequency, right?
But the geometry
I
may
imagine.
cancel out certain fields, so that's
Yeah,
why
that's
I'm
true.
saying Gerald would know better on this because
But
the-
He
That's a good
would. That's a
question,
good
though.
question for Gerald. But
Yeah.
we're gonna get ready to switch over to Faraday Research's League of Extraordinary Inventors, guys. I
I'm
really
gonna log
appreciate
off
you
real
guys.
quick so I can go pee.
Yeah. You're good. I'm gonna end the stream here, and if we can, we'll put it up on my channel as well. But we might not be able to. So I have the link in the chat right there for everybody interested in catching the League of Extraordinary Inventors for Free Energy
The
Fridays.
league.
Thanks, everybody. Peace.
So